Hey Ramblers, this video is going to teach you about indirect proof. It's also called proof by contradiction. It's not like the two-column proofs we've done, which are, I guess it's called direct proofs, but an indirect proof will be done in a paragraph form, and I'll show you all the steps in the format I want you to follow. But the idea behind it is that sometimes it's difficult to prove something is true, so we prove that its opposite is false, and that's why it's called an indirect proof. In fact, defense attorneys often use this to prove that their clients are not guilty, because it's difficult to prove someone's not guilty, but it might be easier to prove that some kind of a contradiction is reached if you assumed he was. Let's take the example of the O.J. Simpson murder trial of the 1990s. This was the center of a media frenzy, as O.J. Simpson had been a very successful NFL running back and Heisman Trophy winner from USC. Yet he was accused of having murdered his former wife, Nicole Brown Simpson, and her friend. There was a lot of evidence that indicated O.J. might have done it. There was a black hat, like a wool hat that you'd wear in the winter, that had his hairs in it. DNA evidence proved that it was, over 99% sure belonged to O.J. There was also, perhaps the most incriminating evidence, though, was a bloody glove. It was a left-handed glove that was found at the crime scene, covered in the victim's blood. And the right-handed glove, which was the exact pair, was found at O.J.'s house. So there was a great deal of media attention, and this was kind of one of the main points of the prosecution's argument. The famous retort of the defense was that the glove didn't fit, and if the glove didn't fit, you must acquit. So let's take a look at how the argument might have played out. O.J. Simpson's defense team might have presented something like this in our geometry class. Proof by contradictions will always have kind of a structure that I want you all to follow. And the first one is that you need to title it Proof by Contradiction, so that your reader knows the series of statements that follow are intending to lead to a contradiction. All right, so that's the first thing we'll put in. The second is that you must lay out all the possible conclusions. So in this case, either O.J. murdered Nicole Brown Simpson or he did not. It's one of the two. It can't be both and it can't be neither. So what a proof by contradiction does is that we're going to assume the opposite of what we want to prove. Now, the defense attorney wants to prove his innocence, so we're going to assume the opposite, that O.J. did the crime. Now we're going to follow a line of reasoning. So if O.J. did it, then he was the person wearing the bloody glove found at the murder scene. But as we'll see in a minute on a little video clip, the glove found at the murder did not fit O.J. Simpson. Therefore, we've reached a contradiction, and our assumption is false. Since our assumption is false, that O.J. did it, the opposite assumption, that he did not do it, must be true. And that's essentially a proof by contradiction. Okay, let's take a look at a couple of examples from geometry, and we'll finish up the video. Okay, let's look at number 1 in section 5.1 as an example. Here we're given that AB is congruent to AD. And we're told that angle BAC is not congruent to angle DAC. Now that's the first time all year we've been told something is not congruent in the givens. But the real telltale that we should be using a proof by contradiction is that they want us to prove that segment BC is not congruent to DC. All right, now let's take a look at the proof by contradiction, and again, please take careful notes on the format here, because I want all of your proofs by contradiction to contain these elements and to look the same. Okay, so our proof will look like this. We always want to have the title, Proof by Contradiction. And then you're going to point out the two possible conclusions, or in fact, all the possible conclusions, but there's usually just two. So either BC is congruent to DC, or it's not congruent to DC. There's really no other possibilities. Since they want us to prove that they're not congruent, a proof by contradiction assumes the opposite. So we will assume that BC is congruent to DC. Now we're going to need to use that assumption in our proof, or else you won't get anywhere. And that's usually the problem students have as they try the homework. They forget to use the assumption. So I'm going to assume that BC is congruent to DC. All right, now we're going to follow a line of reasoning here, and hopefully we'll reach a conclusion. So we know that angle B must be congruent to angle D, because if the two sides AC and AD are congruent, then the angles must be congruent. It's also given that these two sides are congruent, so we know that triangle ABC is congruent to ADC by side angle side. Okay, but then angle BAC would have to be congruent to angle DAC by CPCTC. But we're given that the two angles are not congruent. So this contradicts the givens, so our assumption is false. And segment BC must not be congruent to DC. Since there's only two possibilities, and we showed a contradiction when we made this assumption, the opposite is true. Okay, let's take a look at one more example, and then you can get started on the homework tomorrow in class. Okay, our second example is number 3 in section 5.1. And here we're told that segment AC is perpendicular to BD, and that segment BC is congruent to segment EC. They want us to, we're also told that AB is not congruent to ED. So these segments here are not congruent. And we have to show that angle B is not congruent to angle CED. Well, I want you to, again, pay close attention to the different parts. There's 6 parts that I want you to have in each of your proofs by contradiction. So let's go through them. Well, in the proof, we're told, I want you to title Proof by Contradiction. Now we're going to lay out the possibilities. Either angle B is not congruent to angle CED, which is what they want us to prove, or angle B is congruent to CED. Since this is a proof by contradiction, we're going to assume the opposite of what they want us to prove. And so we're going to assume that the two angles are congruent, and we're going to use that in our proof. Well, since AC is perpendicular to BD, angle BCD and ECD are right angles, and therefore they're congruent. From the givens, I know that BC is congruent to EC. Therefore, angle BCA is congruent to ECD by angle side angle, which would mean that AB is congruent to ED by CPCTC. But this contradicts the given that AB is not congruent to ED. Thus our assumption is false and the two angles are not congruent. Alright, so what are the parts you need? Well, first of all, you need a proof by contradiction. That has to be there. And then you write out all the possibilities. So that's the second part you need. Then your assumption, which is the opposite of what you're trying to prove. And then a line of reasoning, which, if you're doing everything right, should reach a contradiction, which you need to point out as the 5th step. Finally, you have to conclude that your assumption was false and that what they wanted you to prove was true. Okay, that's a proof by contradiction. Good luck with those.